tryptophan.
Okay.
Dimethyltryptophan.
And that's where we want to get to.
Well, tryptophan.
Hello, everybody. This is Empty Turtle. I'm here with Dr. David Jubb, and this is Jubb Talk, and we got a good one for y'all today. It's called the terrain of the body. Dr. Jubb, what is all about the terrain of the body?
It's a great topic for our audience to hear a bit about. Words, of course, are brand new, some things. So, for instance, like the terrain and a mat that is like the sustained mat of the earth, that's a lithosphere and litho-life colloid, meaning light element, like mineral, and it breaks down into life colloid and colloid of life. Have you ever heard of dust we came from and dust we return?
Oh, absolutely. And not only do we come from dust and we return to dust, but we're full of dust, bull dust. How long have you been studying this colloid business, Dr. Jubb?
Dust, I would say, I'd like to call it, if it's all right, colloid of life.
Okay.
Because it's the colloid of life that actually that made up the dinosaurs and everything of the time past, which is making you up today.
Okay.
Could you imagine actually if you've got a bubble and it's underwater, what happens when you try to cut it?
Well, I guess, I don't know. I've never I don't know. That's a good question. Let me guess.
Yeah.
When you have a bubble underwater and you try to cut it, unicorns jump out of it.
Okay. So you can see a bubble, of course, underwater. That's a good image.
Yeah.
If you're running a blade or something through it, you can't cut it.
What?
No matter what you do, you're not going to be able to cut that. Okay.
Can you get through it, though? Will the blade go through it or around it?
Your blade is just going to pass through that, and it's going to remain as a bubble.
Wow. What if you do it real fast?
Same thing. Okay. When you do it fast, like you could do sonoluminescence, and you could explode it, like certain crustaceans are able to do. They could crack glass because it's similar to a 22 bullet.
Oh, the shrimp, that one shrimp that has a really amazing punch.
So you could go so fast, matter of fact, that you create a bubble of itself and it collapses into itself. You see? So implosion as a force is really something. But coming back to a colloid of life, you just, no matter what you do, they're imperishable. You could subject it to radiation and heat and all things like this, and you won't destroy it. And matter of fact, at certain temperatures and things like that, they can multiply certain sort of life colloid that assemble from colloid of life. The colloid of life is a tiny, smallest building block of life itself, and it has life, and we have life vicariously because we're commanding all of those life colloid within ourselves.
You know, it's funny you should say vicariously, because right now in this podcast, I'm learning vicariously through you. And
everybody is.
I hate learning.
Yeah, so that's so good because the average person sort of out there is they've got a certain genre of a thought about information, don't they? And so, for instance, like
so many.
You could see that never just about has it been that there hasn't been a type of a bias going on. And so that's something, isn't it?
Yeah.
Biasness is sort of selective. So where I've selected something or somebody's selected something, then they select other things which relate to what this is. And so that's called a selective sort of a bias. But deductive reasoning is more when you let go your bias, you don't have any bias, and you're given to put things simple as it is, logic. But like at some point could it be like this all gets messed up a bit when Pasteur Louis got funded by a charitable organisation that kind of really wasn't too charitable at all. It was actually really funding because a lot of machinery would be produced and money from pasteurisation.
Who's Pastor Louis?
Louis Pasteur was a brown noser who everybody will say this is the most scientific thing they know, and it's a great example of what pseudoscience is today. And it's like pseudo, I don't even know I would care to use that word. It would just be like
Pseudo?
Unscientific, you see.
I would use it in a title of a soup.
Yeah. But so all of us are using words that are sort of being given at the moment, and we don't even know that they've all been selected themselves just because somebody wants to have a conformity, and fact that doesn't fit with the doctrine is sort of not looked at. But we need to actually look at Pasteur.
Pseudo beef soup. There you go. I could use it in a soup name.
For the longest time, what I've done is to teach people, to move more toward plant-based food.
All right.
But you brought that up. We're going to come back to Pasteur in a second.
All right.
But we're talking about a meat soup, right?
Pseudo beef soup.
Yeah.
I'm talking about a name.
No, I'm going to ask you, like, when you bend over and pick an apple up, you feel okay?
I feel all right.
Yeah. And then when you see a cow, or because you talk about a cow probably, sort of talk beef, okay, cow. A cow's in the field now. Yes. What do you do?
Well, for one, I keep those two things separate.
No, I'm asking like the cow in the field.
Yeah.
What do you do?
I say, hey, cow, how you doing? Can't wait to see you later on the table.
Okay, so do you think it's normal that someone would kill the cow? You're going to kill the cow?
Somebody is, not me. I won't do it. I refuse.
Yeah, but
I love animals.
But if you did that, but you've got a pleasure after it's been killed, right?
I think maybe some people do.
But you have a pleasure afterward, right? It's
yes,
like
when
most
I eat.
People. Yeah, okay. Yeah. But you didn't have a pleasure to get it.
No.
Okay. So do you have a feeling that you and everyone else that's listening that actually has the same view could learn how to feel in their heart again?
Yes.
Because, do you have a feeling that most people they're very conflicted? I mean, all people, basically.
Well, I
would you say?
I think you're right. Yeah. And I think just by, asking me the question, my heart is better right now.
Could you imagine just for a moment
I don't want to eat cows anymore.
That...
you heard it here, folks. I'm done eating cows.
There's molecule that's in there that's a surfactant, and that surfactant is deadly. You see, it's not something that's not deadly. It's deadly. It really is. Why? Well, because you can see all the silicylus, which is sialysis, which is an inflammation of silica of the nucleus of cells. And within that, you could see that you've got an inflammation, and pretty much you can find N-glyconeuraminic acid there that's found its way into the nucleus of the cell, and that's a surfactant that's come from cows, for instance. That's just one surfactant out of 52 different sorts of surfactant which interfere with DNA and cause our body not to have ease of ability to be able to break it down. So long before the gene study was finished, right, in 1000 2002 or something, we already could see that a construct did exist, because you couldn't put pharmaceutical into a base of animal fluid or something without it becoming toxic, you see.
Not good. Toxic, that's a bad word. Popular,
but if we put that aside again just for a second and only just think about asymmetric warfare, if it's pennies on the dollar that you could clear away an enemy, so could an enemy, for instance, be a corporation which is run wild itself, but it could have its own internal regulation, but it doesn't, and it's being regulated from the outside, because none of us, which is below the dead corpse, and the corpse can't think, hear, feel, see, nothing. It's not going to hear a baby cry or anything. And if you put a corpse above your head, like you're latched as a corporation, and nobody ever considers these sorts of things, you're going to find a lot of things which information-wise is biased like crazy, and also too commercial non-stop. And so where is it and who is it? And in the past it was like, for instance, there was a court case in England that related to whether or not we could have fiction or not.
What? Come on.
Yeah, no.
Get out
because
here.
Because actually it was like, back then it was an idea thought that, well, we should have things that's literal, and what would it happen if we start to actually just encourage illiterate? Illiterate means just sort of not something literal, so many things is not literal, you see.
Can you give the listeners an idea of what year, decade that happened?
Around Robinson Crusoe, because it was actual that he came back to England eventually, and he had a story, and he went round, the shows and everything, and he had this story. And someone picked up on the story, and they made another story about this.
What decades?
But they changed the whole thing.
When did Robinson Crusoe exist?
Oh, in the Caribbean, in the days of the Caribbean, it would have been in the 1800s early or something, you see. Yeah.
Okay. All right.
And,
And so they had to decide that this guy, so we don't want him to just have everybody making up beautiful stories.
No, he was adamant that the story that he had, he didn't care for someone to have stolen a story, and changed it around, like, the truth of things, and made it into fictional something when it was really a true story, you see. Yeah.
Wow.
Okay. But the question is, like, if you allow things that's non-fictional to be only, but then if fiction is mixed in with it, it's sort of like this is the sort of thing going on, because when you search for something, you're going to come up with a game, and it's going to tell you about a game, because people are searching for the word, because it's now part of a game, you see. And so you're getting how it's being defined in some game or something, and this sort of thing. But we've got to come back to Louis, because he did an experiment, and it was really to do with his spontaneous generation of life colloid. Is it so, or is it that something happens and it stops and blocks that?
How does the colloid relate to the cell?
The colloid of life, for all life, will come from rocks and things broken down into colloid of life, and colloid of life, smallest building block of life, form, aggregate, fuse and differentiate into a life colloid. And so a life colloid first is a spore, and so it appears as a spore. Most are looking at things like this and they think it's sort of dead because it sort of looks like a crystal or something. But you could see under more sophisticated microscopes, and you could see these are more ovoid and things.
But is the colloid larger or smaller than a cell?
Oh, it's extremely minute. You're coming down to, the very small building block of life itself.
Wow. Okay.
So it is life, because it has Brownian motion, it moves around, it resists the pull of gravity and things, and it itself is of a capacity to sense within its dimension. It has a space, and that space is like a resonant cavity, and so that resonance is actual, and it could sense that through conduction of the adjacent quanta. And so it's like a conductive field in the vacuum. And because it looks to be simple, that something is just empty, it seems, but it's not, you see. So if you could see that lightning travelled from the ground up into the sky, and you saw it didn't need a wire to go there, and that today you can have lasers direct those where they are, you see, and you can direct the lightning and things. But
so the colloid is what builds our body's terrain.
A colloid of life travels up into the air in the atmosphere,
Colloid?
and it is the very substance which causes rain and water to form, and so cloud and then what have you gathers, and then it rains back down on the earth. And so you've got a hydrological cycle which goes right down into the earth and then comes back out again. And as a water, it's at 42 degrees Fahrenheit, and it's called a structured water. But coming back to Louis, he took some urine flasks and boiled them. And so his mission was to show that you could basically cook something or boil it, and so then there'd be nothing more that could arise from it. It would be sterile. And so this was sort of an idea they had, because they thought to themselves they're going to pasteurize wine, but most people couldn't stand it because they didn't want to cook their wine. And every time they tried to cook it and temperatures and stuff like that, it never tasted quite the same as it was when it was fresh. So they had to figure out how to do this. But Louis was there in the clean room, right, and doing everything he could to make these flasks sterile, but every time, no matter what, only just hours, even days later, it would be full of a virulent material, and it would have life in it. It would be turbid, and so it kept doing the experiment to see that he could actually seemingly perhaps do something and it wouldn't be contaminated or something. And this was something that was on their brain, because they were only thinking in terms that little things that were invisible could attack you or sneak up on you, and they could take your body over, sort of thing. And so this was an idea of little things invisible that could attack you, but it wasn't an idea which was a long time idea of common sense, which was that things broke down into colloid of life, and a colloid of life then assembled into life colloid.
Movie title, Colloid of Life.
So when you take quartz crystal and it's ground very fine, and it's mixed, it's spun, and you spin things to the right, then you spin it back to the left. Every time you stretch something, it becomes imbued with energy. And if you look before under a microscope at what you had, you'd see just the raw material of the existence of those things good. But after a moment of time with notes that you could also do, where you're bringing energy in, you're going ka-doom, ka-doom. And that's an energy in, like whoop whoop is an energy out. And so sound itself, is a three-dimensional form of energy. You see, and light is just simply sound with a luminous quality.
What dimension is the light? Three-dimensional also?
Yes, it's three-dimensional. It comes out more, but basically sound is three-dimensional. Light is conducted on a plane, and only that we could see light because it is conducted more on a plane, you see.
Yes.
But coming back to Louis, we just said that experiment, every single flask was turbid afterward, you see. So Beauchamp was a man at the time, if you look into this, it's wonderful. You could see incredible research and insight into spontaneous arising of life colloid, which they were trying to figure out what name they might call all of this stuff. Where I came along in the late 70s, I was just looking to see that there were just so many names about all of this, but in fact it did exist, and many people had names for it, and I just gave it the English word life colloid because it was a colloid, and it had a structure as a colloid, and there were various phases of a structure of a colloid. It was something which was interesting to me at the time because I was interested in H3O2 because I did see that there were 3 types of water. And so that was interesting because I saw that when you cook things, and they were doing vaccination and stuff, which was not for me, I was looking and interested in how could something be absorbed more across the tongue. And to do that, I really had to study the physiology of this.
What does the colloid shape look like?
Ovoid. It's an ovoid. Yeah. So if you go down,
what's that?
Ovoid, meaning it is only something with a curve. There is no such thing in life as anything with an angle.
Ovoid. It's ovoid.
Right.
That's
and
a T-shirt.
Also,
Boom. Ovoid.
Also, there is no such thing as anything straight.
What? Come on.
There is nothing parallel either.
All right.
And
I'm looking at a pretty straight
anything
table.
Spontaneous, right?
Oh, they're spontaneous.
I'm
spontaneous.
No, spontaneous. I mean, I'm talking about in the similar moment because it doesn't exist.
What?
Right. Also, no 2 things are like each other. Yes, there's a small difference, right?
Dr. John.
Yeah,
Dr.
you see.
John.
So there's not symmetry in nature, right?
Really?
No.
Come on.
Yeah. So
What about like patterns in a leaf of a tree?
Yeah. If you went somewhere, we'd know you went there because you'd leave patterns which was not natural.
Me?
You see.
Of course.
Well, our species at the moment, wherever we went,
I have a rather
because we
large
haven't
head.
thought about those sort of things. But the terrain coming back is a real focus, you see, because it's the environment that's surrounding your cells.
Okay.
So, for instance, like the cells that we have only make up a small percentage of your actual body. The largest percentage actual is more made up out of life colloid, which isn't your cells of your body, but you're commanding all of that.
Wow.
And then the other thing is that a lot of substance that we have in our body has its own DNA, and it has a schedule for its own self, as its own, reproductive schedule inside a cell, for instance.
That's amazing.
And so a cell is made up out of individual life, which a cell is composed of as a membrane, and within it you have organelles. So, for instance, you've got ubiquitin life colloid, which actually comes from the outside of the body, which we'll talk about in a second. And then because the cell is born blank, and then certain things happen in its environment, and without those things occurring, the body doesn't have a capacity to be able to heal itself and a whole range of things.
What a coincidence. Babies are born blank as well. Hey, but I wanted to ask you about the cell. So if the cell is conscious and they're individuals, do they know that what they're doing is for me as a human or a person?
So far we've said a cell really is composed of individual life colloid.
Okay.
Yeah. So, nature is a mutual lived assistance.
Mutual lived assistance. Yeah. Oh, T-shirt.
Because you can't find a cell by itself somewhere. You know what I mean?
Yeah. Okay.
And Virchow was a bloke, a long time ago, and he was sort of really getting things figured and thought. And he said only a cell must come from a cell.
Oh, wow.
And so this was an error because obviously it didn't.
Really?
And so, nobody was able to come up with how it arose. And that's more the work that I did. I sort of looked into how does a cell arise? And it arises more through a pleomorphism. So we've been talking about pleomorphism just right now because we've been describing how colloid of life cycle exists and that it can become a life colloid. Okay. And that life colloid has a spore. and then the spore becomes a double spore, and that becomes a building block of all organelle of your whole of your body. You see?
You said something with pleo. What was that?
Pleomorphism is a many-changing form, which we're talking about right now.
Pleomorphism.
So, in other words, like a hippopotamus can become a bald eagle, right, at this level.
I hope the listeners are paying attention. We've been talking about
below the level of a cell.
And, I'm with y'all listeners. I had no idea we were talking about that.
So the terrain is everything, because a cell is surrounded by
what?
A glycopacking, which is made out of colloid of life and life colloid. And that glycopacking causes the cell to have the capacity to be able to have a slight vacuum outside itself, which pulls things more outside itself. So it's holding onto itself a bit, but it has the capacity to be able to have material release from itself.
Doesn't our planet have a vacuum outside itself?
Well, water itself is like that because it's empty relative, and it can bind. The hydrogen can be bind with things and cause it to become solvent and transport things.
We're living in a cell. That's what's happening.
So
I just figured it out, folks. Living in a cell.
And so you and I really are composed of a multitude of life, right?
Yeah.
And a lot of it isn't got your DNA per se, but the DNA of its own self and things. And so the terrain, well, could we just say that's around a cell, our focus should be on?
Sure, absolutely.
Yeah, because at the moment we're living in a world that's unscientific mostly.
All right, terrain?
And that the world we live in is mostly unscientific at the moment. Okay, so we're guessing and coming up with things, and we're describing action, so it's really describing an effect. So we're talking about the effect, and we're learning how to use words to describe what that effect is. You see, yeah. But the terrain and the focus is on everything. Where the environment is that's surrounding our cells, it's pretty critical, and that it's not the cell itself. Could you imagine that? Because, so for instance, if a cell was in a dry environment, it wouldn't be able to live. If a cell was in a wet environment, it might not be able to live. If a cell was, in an acid environment or alkaline environment, more than what it should be, it can't exist. And so the focus has been in the world pretty much a lot about the cell itself and what the body is, but the condition of looking at the terrain, the terrain is everything. And so there's 3 benchmarks that you could look at.
Okay.
You see, that is science. Okay. If you don't do this, that's pretty unscientific. And
well, let's hear them. 3 of them. Let's go. Come on.
I'm just looking at what's going on the net.
Yeah.
But I don't even have to do that. You could always see in the past quite a bit of a bias going on. Mm-hmm. So, where would I want to start where that is, you see?
Sure.
So, or pick on anything itself, because it's actual that you and I actually really have to have a little more logic in ourselves.
Well, we'd have to have, for one, this where to go. Oh man, it just depends on who you are.
Let's simplify it, because it's really great, isn't it?
3 benchmarks.
Three benchmarks. So one, so when you have 2 glasses of water,
yes,
and one's got some ocean wind evaporated solar, minerals in it from the ocean, there's 92 trace elements in there.
Wow.
And the other one is just empty, it's void, doesn't have anything in it. You've got a multimeter, and you're looking to see, you put the probe into the water of the glass, which doesn't have anything in it, and no light comes on, no energy has existed there. You can't conduct. Nothing can be conducted. Whereas put it into the other and the light will come on, And so the conduction has occurred between the 2 probes to complete a circuit to cause a light to come on.
Okay, benchmark number 1.
Number 1 is that we have in our environment around our cells a conductivity.
Okay.
Yes? Yeah. And you can measure that, all right? Okay. So let's see. So that's a very important benchmark. That's in the environment around a cell. And what could be some things which could block and stop conduction?
Clutter.
Yeah, so like, could you think that there could be sort of debris like fats and things like that, which could cause insulatedness and not let proper conduction happen because it is insulating the conductor?
Sure.
Yes, so you've got substances which come in and those things which cause the body to have lost its proper conduction, and you've got things which rob mineral from the body and things, right? And so then that causes the conduction not to happen as proper. Okay, so moving on, we've got two more because we've got so much we could cover.
So what do you call number one?
Conduction?
Okay.
Yeah, conduction.
Number one benchmark, conduction.
Yeah, there is a conductiveness. And in a plant, in botany or biology and things, you really can have a measurement of the conductivity that's existing through the tissue or the fluid. All right.
All right, two.
Okay. Number two is there is a negative redox. And that's like how much antioxidant that you have, how much capacity do you to have to neutralize free radical types of oxygen molecules.
Free radicals can be a problem.
Well, free radicals are necessary to have energy.
Oh, no.
It's managed, and so you have oxidants and antioxidants, and oxidants cause antioxidants to arise. Without oxidants, you can't have antioxidants arise. So these two things all work together. But let's just chill just for a second because let's see. Now we've got we've got a certain capacity of a north negative as a static kind of a bank account, like in a battery when it's called alkaline. And when you've got a lot of north negative in there, it's stored up and it can be released. And so you've got a flow of energy that can flow toward a south positive to get work done. And in our body is like a wet cell battery. And you must have a north negative substance, and it's so important, matter of fact. And it's the very substance that slowly but sure comes to be missing. But we're just at this moment, we're only talking about the terrain, and cells have to absolutely have a proper condition that they live within, otherwise they age. And this is what disease is, and neoplasm, which many people would die of a neoplastic condition today. And you're looking at people who go to get surgeries and all sorts of things. And most people, if you asked, why is it that they do not know what neoplasm is?
Neoplasm, please tell us.
Well, it's just tissue beyond the economy, which should be there.
Say again?
It's tissue and debris beyond the economy kept in the body, which shouldn't be there. It's beyond the economy of the body. That's what neoplasm
I'm trying to keep my head from exploding.
And so the terrain not kept clean. If you put dust into a camera, you'll never get it out. If you put various things into something, most people, if you ask them, how do you get that out? And they scratch their head and they haven't even ever thought about how do you get something out. Where things go into the body, it definitely tattoos the body, and it never ever is going to come out. And that's the reason why you can find cocaine and coffee and chocolate with all the mummies all around the world around the same time. So we had a great fusion. People were sort of trading a lot of things back then. But the terrain is the focus evermore, because you've got an environment, and it's surrounding our cells. So, for instance, so far we've just said, there's a negative, a north negative, and that is a negative redox, and that has to be around about minus 71 millivolts.
Is that good? Because it sounds bad.
When you have a PQRST complex and it neutralizes itself, right, it goes into space. You've got an A field, like a trajectory into space, and it's absorbed.
Right.
And it's absorbed by 10,000 times faster than it went out.
Dang.
And so
That is
that which absorbs it neutralizes the charge, and that neutralization is around minus 71 millivolt in our body. So if it's not, for instance, like when somebody's sick, it could, or not well, the cleansing, the amplitude and the strength of the current and things travels in a manner that it no longer is able for a current to depolarize itself. And so a muscle can remain polarized and constricted, and various substances that we bring in assist cause blood vessels and capillaries to be relaxed.
Is that good?
Yes, because now circulation can occur if blood doesn't flow around the cells and gases and things that's like that. Right. And so, for instance, you've got life colloid in the air, and that is fresh air. And so fresh air does have substance in it which stale air or air out of a can doesn't have. And so you see these things really, like ions and these sorts of things, magneton, positive, negative, a neutral charge magneton is a field around our body. And so, for instance, like when you've got that field around your body can have life, and when we don't, our body really doesn't have life. So basically, in our program today, we've really been talking about a terrain, and that the terrain is everything. And that's what Pasteur said on his deathbed, when it was last thing that he said was, the terrain is everything, and the cell is nothing. He basically said the terrain is everything, because he was holding that absolute observation and science back from everybody, just to keep going with the idea that pasteurization would work, because a lot of money started to flow in because wine started to be pasteurized.
Here we go. We're going to take a break. We'll be back before you even know we're gone. Is that even possible? We'll ask Dr. Jubb when we get back. All right, we're back. See? You didn't even know we're gone. Okay. Dr. Jubb, you've been talking about colloids and all this good stuff. What's it all leading to again? Remind me, please.
Okay, so everything that is about cell respiration and the cell being able to be respired, and the importance of carbon dioxide in the picture of what this is, which has often been just not considered, but it's an extremely important gas, because carbon dioxide, for instance, is a smooth muscle dilator and a sphincter that are around capillary are made of smooth muscle, and so you've got an autonomic nervous system and sympathetic and parasympathetic connections to your capillary, and it sort of decides, you've decided whether something is going to flow or it's not going to flow, and how relaxed somebody is in their shoulders, how relaxed you are in your breath, and these things, all something which is being passed on, because it's like a state is passed on, in fact, where we are, you see. So even let's see, the tone that we use, or the note that you use, these are all things which you can hear, like echolocation, and these things you can hear from the sound that's being made, what the condition is inside a body.
Would all this be considered part of the terrain of the body?
Yes, it is, because you've got a conductivity, you've got negative redox, and one more, and that is parts of hydrogen. So, for instance,
of hydrogen.
Yeah, how many parts of hydrogen is spare? Okay. So, if you've got a lot more spare parts of hydrogen, it's more alkaline, and the less that you have, the more it's been held by South positive, and nothing is free to flow. And this is a battery which is dead, basically. Whereas a battery that's live has got a bank of north negative within itself, or a capacity to be able to draw upon it. And so, these are the things which allow us to be able to have a dynamic magnetic current flow in the body. And so
dynamic magnetic current.
The blood and plasma is on the outside of the cell, and that is supposed to have a pH of parts of hydrogen of 7.3 to something like this, right?
Yes.
And it shouldn't be 7.4, which is really high. Every little decimal place that it goes, it's actually an exponential number, really quite large. Matter of fact, the difference between the two is huge. And so suddenly the blood has shifted in the last 100 years or more from since it was being taken, and it's shifted more to be more alkaline than it was. And so it's now around about 7.4 or something in the tissue of the body, which if you minus the DNA and you've got the fluid within the cell and things, it's around about a pH of 6.8. And so what you've got is a very slight difference between the inside of the cell and the outside of the cell. And so this causes a non-stick or a manageableness where things are basically able to have a uniform tension. But when that changes, it becomes more, polarized, and things no longer have their proper surface area.
Dr. Jubb, that is fascinating. I tell you what, but I have a question. You brought up alkaline, and I just want all the listeners to know out there, and yourself, is it possible? Because I actually, instead of alkaline, I prefer Duracell. Now, wouldn't that make a nice little commercial in our podcast? Maybe one day somehow I could stick something like that in of a sponsor.
I think that it's a great example of how commercial information comes into things and where does it fit per se.
Perfect, that's right.
Something that you would love to mention is like a name of a brand.
Sure.
And in 2,000 years, that might make sense, it might not.
What?
But it's a lot of things that are going on where language is itself, in fact, actually.
I'm thinking in 2,000 years, that's when it'll make sense.
Our blood group, like you've got A, B, and you've got O types of blood and things, and blood groups refer to sort of a red blood corpuscle. That red blood corpuscle isn't a cell, of course, it's a life colloid. A cell is a life colloid, and a cell is made up out of life colloid. And you've got blood-brain inhibitors that block and stop the expression of that double spore, pleomorphing into a life form which is fermentive versus aerobic. And so you've got anaerobic, meaning without oxygen, and you've got aerobic, meaning with oxygen, and you've got types of conditions where you can get energy. And so there's a halfway down our citric acid cycle, you've got energy being created and transferred down, going from one thing to another, and you're starting with blue and you're ending up with red. And if we've got iron in our blood, and it sort of really is how energy gets transferred, basic. But
you've got clogging your arteries.
You've got conductivity that we talked about. You've got parts of hydrogen, and you've got negative redox, and these things all create a cellular terrain, and only within a specific region, right? For instance, like a temperature and things, can something function. So, for instance, a red blood corpuscle, if it's within a range of 98.6 degrees Fahrenheit, which is its temperature that's supposed to be at, when it gets below that by several degrees or something, you can start to see that potassium is no longer held in the red blood corpuscle. And that's a fact of things, you see, because potassium on the periodic chart, it actually really has a spare north negative. So it's 18 usual, but typical it is of proton, but it's got a spare north negative. It's got 19, on the outside of itself. And so, but it could easily lose that, potassium does, and it has a function to be able to come in and outside of a membrane and these things, to be able to create a sodium-potassium condition that causes a dynamic current to go across your cell. And so, basically you've really got energy in a magnicity, and without that, sort of we don't or can't get any work done, basically.
No, can't at all.
So aerobic glycolysis is fermentation, and that's where protein and fat is broken down through the Krebs cycle, and you can get a couple of adenosine triphosphate molecules, which is called just an energy molecule.
I knew there was something
ATP.
good. I knew there was something good about beer.
And so that could do this without necessary presence of oxygen, and also do it in a lower environment energy-wise, which it could. And then these things switch your DNA to have gone back to a condition which is more fermentive, which is a recapitulative conditioning of the past. Because when you and I started out, we only were as a 3 or 4 or 5 cells, and everything grows from everything else. It's sort of, we weren't even cells. We were simple endoblastic fetal cells without anything differentiated at all, and we were only in a fermentive state at some point, and every bit of substance was turned into growth. But when that finished at the differentiation of the cells and the body, an arrested embryological developmental stage was existed for every organ, in fact, and like an eye, an ear, and things that's like this. And so switches exist in DNA for aerobic glycolysis, which is fermentive in a condition of fermentation, and it produces sort of like shells like chitin, resin, and sclerotin. That's quick, in the
I have a question.
Outside skeletal structure of a mold or a fungus in a yeast.
You used a word called reclicipative or something like that?
Oh, re something meaning do it again?
I don't know.
But what would we be doing again?
Reclicipative, or I don't even remember. I guess we'll have to go back and figure it out. Reclicipative?
A past. You have a past. That's right.
What was the word?
Just means you have a past.
Well, what's the word? I can't remember.
A recapitulative.
That's
a recapitulative past.
Now, before I say it, would that make a really good T-shirt idea?
Right? A recapitulative past.
No, just
recapitulate.
No, recapitulative.
Oh, recapitulative. Yes.
Would that be good on a T-shirt?
Well, people could have a better vocabulary for sure.
Yes, definitely, right? But is it a good thing or a bad thing? What does it mean? Is it?
Oh, recapitulative means simple, that something is based upon the things more or less that it arose from, and something existed back then, for instance, like we said, which when you were only a mass of fetal endoblastic cells, we were saying that was getting your energy from aerobic glycolysis, which we said that you could get energy in that state when energy was sort of like, not much, like maybe minus 20 millivolts or something, and not minus 71 millivolt, for instance. And because you've got a condition going on which is a mass, and it has to eventually have oxygen and carbon dioxide and things like that coming to bathe itself. Certain cells that we have, like in our mouth, our throat, and nose and things, have a capacity to be able to draw life colloid, aerobic life colloid in from the air, which fresh air does have this, you see, whereas unfresh air doesn't. But
all that from one word.
Well, a recapitulative past only means that we just said that if a DNA switch exists for fermentation, that could be turned back on again, which it is in disease. It is when a condition existed where energy couldn't have been produced proper in a niche somewhere.
Are we fermented?
150,000 cells like this are produced every day, and providing that you have pancreatic function when you sleep, most of those get cleared away. And so a condition is ongoing, and then that has to be something which is get cleared away, you see. But life colloid transmutation of the terrain really is everything. and the amount of spare north negative available is your negative redox, like we're saying, and the mineral that's present in the that gives you a conduction, gives you also a dynamic capacity to have a magnetic current there, and parts of hydrogen inside the cell membrane in relation to what's outside causes an isotonic, means similar tension relative. If the tension is too great, then it causes a sticking condition on the membrane, which this is really not a correct condition for the cells to be, because it actually happens that you have a good surface exchange where everything is kept of its proper membrane and surface, but if it's all clumped up, suddenly you really don't have a proper surface area there. So when finally when it's organized itself, like as a body, it shifts beyond aerobic glycolysis, and it shifts into oxidative metabolism, and this is you getting energy, and you're getting 38 adenosine triphosphate molecules. You see, you're getting another 36 plus the 2 that happened above, and so this is very efficient sort of energy, basically, you see. And this is actually kind of really what goes on where, we have like a life itself. Nitrous oxide, when you laugh or as you're happy and things like this, opens up it's a smooth muscle dilator and opens everything up. The same as carbon dioxide does too.
I like that.
And so when somebody would have breathed it all off, for instance, because they breathed through their mouth when they slept, for instance.
Can we make it on our own, in our bodies?
It's a good example of how...
nitrous oxide?
Nitrous oxide, yes.
No way.
Yeah, when you're laughing, you're stimulating and causing nitrous oxide to be created. Or happiness as well, also, like an inner smile. But nitrous oxide is very important because, as we said, and carbon dioxide as well, these are smooth muscle dilators, and they open up your capillaries and things, blood and oxygen can flow, and carbon dioxide can. And so blood is a liquid crystal organ, and in a colloidal state, and it is made up out of gases, you see. So carbon is something you can just breathe off, and otherwise, minerals and things like that you can't really breathe off. The body has to have managed those sorts of things, and so substance has to be orthophilic, meaning straight with nature, and so mineral, for instance, has to be something which can be cleared away versus substance that can't be. And so that's the problem with rock salt. Rock salt could change the environment incredibly because it can't be broken down, and then it attracts water to itself, and water comes to the inside between the cells, and suddenly it doesn't have its vacuum space like it should, and it becomes hypoxic, meaning it becomes truly deficient, and it becomes hypo, meaning full more.
All this is doing what?
The membrane of the cell is inside. What's inside the membrane of a colloid can cause it to be swollen out with water because the cell absorbs sodium. If the sodium is on the outside where it is in excess and not cleared away properly, it can always be holding water there. It's a charge which is just pulling water to itself, not letting water travel like it can. And so, for instance, when salt bags are given to people, after that, at the hospital, you'll see all sorts of infections and all sorts of things is listed, but never before that, in fact. And so afterward, always. And so it's a condition which is changing the environment of our cells and changing it around to be substance which is not orthophilic, you see.
Can our body exist without colloids?
A body is made out of colloid.
So our body cannot exist
in healthy blood, you have colloid of life. And in unhealthy blood, you really don't have any much. In unhealthy blood, you have double spore having already formed more intermold fungus and yeast.
They told me I had non-colloid blood.
When you say they, okay, so who is they first? Or no, but I mean, we all actually say things like that. We say they.
Non-colloidal.
Yeah. So they. Could they be...
I use they a lot when I'm
No, I know.
making
But
bull dust.
they are doctors or somebody or
When I'm
something. I'm not
making
sure.
bull dust up, I say they
Oh, yeah,
a lot,
right.
okay?
Exactly.
Thanks for calling me out in front of everybody, Dr. Jubb. Just kidding.
They is really something, isn't it? You're hearing they all the time, but
I love using
it's a pronoun.
I use it a
It's
lot.
not definable. Yeah, so it's actually.
That's why I use it.
But it's true that groupthink can have caused us to think in a certain way. So at the moment we have a lot of groupthink, which the substance of the talk sort of challenges a lot, because it's sort of bricks that don't fit into a wall where someone has built something, but it causes the wall that's existed to come tumbling down. But you see, where a paradigm paralysis is, it's right that the new paradigm is questioned and the old paradigm isn't questioned at all. And it's true that you come to actually understand what is so, because the new paradigm is questioned, and so it's vetted, and suddenly something comes to be more accepted as truth, you see.
New paradigms, they scare a lot of people.
Well, a paradigm at the moment of the truth being cooked, and the idea that something was sterile when it wasn't, and the idea that something was better afterward, are all things which we could question those things actually, you see. Because when you cook something and suddenly it doesn't have its enzyme anymore, if it were cooked too much, you've lost a lot of value of things. I was one of the very first people to ask those that could do Curlian photography to look at the field and things that was around food which was in an uncooked state and unprocessed versus food that was in a cooked state.
No way.
I looked at a cabbage, for instance, and cabbage in a cooked state had no life. Anything that you cooked would have no life, basically. But it was interesting because you could see different things, like ginseng had an energy field which was exactly like a brain. And so you could see that various things actually could affect and help things, because there was a field which would be invisible unless you were able to do something to cause that field to become more visible as of its effect.
Okay.
And so, so most everything that really is of a living state has a zeta field around it and is suspended. So, for instance, when B17 is cooked, it no longer has that zeta potential. It just settles as sediment, and there's a sedimentation rate of blood. And when you're in good health, your sedimentation rate is modest.
What is the best way to get B17?
B17 is found in all fresh fruits and vegetables. There's 1,700 different sorts of fruit and vegetable which you can find B17 in, but B17, like a lot of vitamins, are extremely heat unstable, and the moment that they go through heat, they no longer really are functional at all, you see. So because you've got to get inside the cell, and ubiquitin life colloid comes into the cell to absolutely help correct DNA and help patch up DNA that's dysfunctional, and correct those things. But basically on the program, that what we've said is that if your terrain is vital, you've got oxidative metabolism. If the terrain isn't, you're going to end up with more fermentive types of condition. When the ferment is, a lot of lactic acid is produced, which is fermentive, and that switches the liver off. And so this is really what neoplasm is, where you turn that around, and things could be simple steps could be given, you see.
Dr. Jubb, I mean, you've been blowing my mind this whole time. Anyways, we do have to wrap it up. But what do you think about this? Should our next episode be called A Colloidal or A Colloid Life?
Perhaps it's wise that we could talk about the colloid of life cycle, and we could talk about a healthy cycle versus an unhealthy cycle, because you've got blood-brain inhibitors that block the expression of the double spore having turned into...
Why a double spore and not a single spore?
It happens to be a building block and a size of things, in fact, it just happened to be a size which is useful to build, but you could say also too, because shape is something which allows structure to be able to hold together. So, for instance, like when you cook an essential fat, like omega-3, omega-6, omega-9, it loses its horseshoe shape and it becomes more like a thumb, in effect, like just thick and stubby. But it will fit into a membrane, but it doesn't, it'll be pinched. The membrane becomes pinched. So when membranes become oxidized, it is because suddenly those essential fats that's there that make up the membrane become oxidized, becomes pinched, and so as it becomes spiked. And so this is a spiked membrane. And so where someone eats fats, which is trans fatty acids, it always creates spike protein, spike fats, and membranes.
Last question, real quick, and we got to wrap it up.
Of the red blood corpuscle.
Got to wrap it up. Are spores attracted to each other like people are attracted to each other?
Likeness attracts likeness. If you look under a light in the night and there was a trough below it, that fed animals or something, a light that would have been on for a bit and then turned off, hopefully God help us it was turned off, but you'd find moths attracted to the light because it's artificial, it's not right that you've got all these lights you see in the night. A moth would have just the moonlight to travel and cause itself to be guided, and so because it goes to the light and they hit the light, now they're all falling because they're dead. But we're looking just at the water and we see that all the moth more or less are floating together.
That's awesome.
Likeness attracts likeness because you've got a magnetic conditioning in a moment where there's a similarity and a sense of fitting, and so where that happens, it attracts more. Yes, it does.
Oh yeah, and you know what?
So
I totally agree.
Likeness.
Everything you're saying is amazing, folks. That's all we got. We got to go. I just want to say, we're going to set up T-shirts soon. I don't know how or when, but the sooner the better. And the only reason, I don't know a time frame. I know it's going to be real soon. It's just I'm really dumb and lazy, but I appreciate y'all. Jubb, say something really good to our listeners to help them with the wonderful, beautiful thoughts today.
Well, life begets life. And dead begets dead. Everything that we do, that we put out, summons a like energy back to us. Yeah.
All right. Take us out. Watch your head.